Now, we've seen a lot of examples of sketching a curve after I've been given a specific function, whether that function was a polynomial function, whether that function was a rational function, whether that function was a product of a polynomial and an exponential, whether that function had a square root in it, and all of that. What if we do not have a described function? What if I don't have an f of x? What if I don't have an equation? This type of reasoning can also be extended in lots and lots of different ways. Knowing some features about a function can tell us how generally you can draw it. Well, think about looking at a pattern. Here we have a pattern. It looks like there's a straight line from basically negative infinity up to 4. Well, we could try to come up with the equation of that line. However, we could also say, well, what do you think? How do we think this pattern is going to extend past 4? How will the function behave after the x equals 4? Now, the most reasonable guess is probably that the function will kind of keep going in about the same direction after we hit 4. And that's all we're trying to get you to do, is to say, yeah, if I have a straight line, I think that beyond 4, we're going to keep that same pattern. All right. Why is this? Well, the same thinking that we were using earlier to curve sketch is applied here. Most of us see that we have a constant first derivative here. In other words, the slope is constant. There's no concavity here. It's a straight line. So we're not concave up or down, but the slope is constant. So what's going to happen here? Well, we'd probably keep the same slope since it's been constant so far. And since the concavity is always 0, we'd probably still keep the same concavity. That's the idea behind these next few examples. Now, how about a more complex function? Well, beyond 4, how is this function going to behave? As you see, the concavity of this function right here looks to be always positive. Looks like we have positive concavity, although you never know what's going to happen beyond. But it would be my guess that beyond 4, this function is still going to go up, at least for a little while. We're going to extend up. Maybe it's going to be have the same positive concavity, so it's going to go up very quickly, or maybe it'll just go up and then start leveling off in the future. But immediately after 4, it looks like it's going to go up still. I want you to think through this one. What do you think the function is going to do after x equals 4 in this example? All right, well, you might say it can do a number of things. It could level off and then a little bit later start going up. Or you could say, well, it looks like it's going to start trending down. It's going to keep that negative concavity, right, or concave down here. So maybe you think, well, it's going to probably keep that negative concavity and do something like this. All right, so your options are maybe it'll start, since it has slope 0 and negative concavity, maybe that could be a point of inflection at which you go 0 and then up after a minute. Or maybe that point is a critical point and we have no point of inflection, so it goes back down. Probably the second, probably the negative concavity, since I don't see any other change in concavity. I'd probably imagine this is going to keep that negative concavity. Well, let's take a look at this example. Here we have kind of a wavy curve. And at the very top, well, this is a little stretched out, but it's 7 to 8. From 7 to 8, it looks like we're concave down. And what I would guess is probably this is either going to turn down, probably most likely turn down, or level off. It looks like negative concavity from 7 to 8, so I probably would keep that pattern. Again, the beginning pattern, we started negative concavity, there's a point of inflection up here, and then we start positive concavity. We're increasing, but then leveling off, and then going back to negative. That's what I would have guessed. You might ask, well, what's the sense in all of this? What's the sense in all of this? This should give you a little bit of understanding of the patterns and things you can see in the future. One of the things you can use this for, one real practical application, is to look at graphs of stock prices and try to determine what they're going to do in the near future using the first and second derivatives. First derivatives is, are they increasing right now? Second derivatives are saying, what's the concavity? Now, this is not stock advice, so don't think that I'm telling you you should pick stocks or anything like that. All I'm saying is that this is one of the tests that people actually use, the first and second derivative tests, to try to predict stock prices, or at least in the near future. The stock prices are not nice, smooth functions. Here's the stock price of Apple today. This is the stock price of Apple December 17th, 2021. So as you can see, it's really bumpy. It's not a smooth curve. So when I say first and second derivatives, you have to approximate a bunch of these things. And so you might say, well, right now it kind of looks like we're increasing. And so maybe in a couple of minutes, it'll still increase a little bit. Or maybe you start trying to smooth out this curve and you say, well, you know what? My curve kind of looks like this. If I drew a smooth curve on this, try to do it. I don't know. Maybe that looks a little concave down there. So maybe at the end it looks like concave down, and so I should sell. Or if you drew it a little bit different, you might say, well, you know what? This kind of looks like smooth. Going here, if I drew it, maybe that looks more concave up. That's the really hard part, right? Is actually trying to come up with what the curve is doing and how the curve is working. A lot of times when you do these types of things, you want to do it over longer periods of time. So if you look at the 5-year analysis of Apple's stock price, again, this is from essentially 2016 up through December of 2021, you see this pattern, and it looks pretty like there's a lot of growth, like it's going up. Anyways, the first derivative would tell you that it's going up. Second derivative here at the end, I don't know if this looks, this looks a little concave up right there at the end. Although, again, this is not stock advice. So I'm not telling you to either buy or sell Apple stock. I'm just telling you this is one of the tools that people can use to look at stock prices and try to predict these first and second derivative tests. It's always tough to match a pattern to these types of stock price curves. So, like I said, this is not stock price, this is not stock or investment advice, but it is something that people use, these first and second derivative tests, to try to see, well, should I buy Apple right now? Should I not buy Apple right now in the near future? All right, so that concludes this section.